In this video, we're going to follow up on some stuff that we talked about in the previous video. In the previous video, we saw that if you have a value of a more derived type, then you can assign it to a variable of a less derived type. So if we have a giraffe in hand, we can assign that thing to a variable of type animal. The question that I want to consider in this video is, okay, suppose we're in that situation. Now we have an animal in hand. We know that it's really a giraffe, but how do we treat it as a giraffe? So there are operators in C# that can do that for us. They are called the is and as operators. We're going to talk about how they work with classes, and also we're going to talk about how they work with value types and with nullable value types. So let's get right into it. I'm going to go back to the example that we had in the previous video. So we'll start up Visual Studio here. And as before, we have a class person. I've added a constructor to that class in the meanwhile. We've got our change request base class. So we can have a change request. A change request is something that has a title and a description and an implementer. And then we made two derived classes. We said a defect fix request is a kind of change request. But the difference is that it also has an expected behavior and an observed behavior and a reporter. But it has all of the other properties that a change request has. It inherited those properties. Similarly, a feature request, also a derived type. And the difference is that it has a requested by. So we have change request, defect fix request, feature request with these is a kind of relationships amongst them. All right. So suppose we make a new person, let's say Eric, and we make a new person, let's say Leah. And we say, OK, we're going to make a new feature request, and we're going to make a new defect fix request. But we're going to assign them to variables of type change request. Now, if you were doing this in a program where you had local variables like this, you would probably type this thing as what it is. You would probably type this as feature request. Right? But suppose that you were passing this thing off to a method that took a change request. In that case, you wouldn't necessarily know what kind of thing you were passing in. So this code here is more for expository purposes rather than realistic. I just want to illustrate how you would deal with this situation of, I have a variable of one type. I suspect that the thing that it contains is of a more derived type. How do we deal with that? So we'll make a feature request, store that in a variable of type change request, C1. We'll make a defect fix request. We'll store that in a variable of type change request called C2. And just for the heck of it, I'm going to make a third change request, and I'm going to set that variable to null. And we're going to see what happens when we try various of these type checking techniques on a null reference. So you and I know that the variable C1 has a valid reference to a feature request. But that's not true in general. The compiler doesn't know that. We could have put something else in there. So if we try to use a property that is only found on feature request, like requested by, you'll see we get this red squiggly here that says change request does not contain a definition for requested by. And then it suggests maybe you intended this to be an extension method. I don't know. The compiler is actually not that smart here. It does not realize that there is a derived type that has this property. And maybe in a future version of the C# compiler, the compiler team could be a little bit smarter about that. But anyway, the error message is correct. There is no such property on an object of this type. So it won't let you use it. So we're going to have to somehow turn this thing back into an expression of the appropriate type. Now, if you know for certain that a given variable contains a reference to a more derived type, to an object of a more derived type, you can simply cast it. You can simply cast the expression, the variable expression, and that tells the compiler, I happen to know that this thing is of the type I expect it to be. The compiler should start treating it that way. So let me give you an example right here. Let's just step into this code, and we'll see what happens. All right, so we make our change request. We make our change request. We make our null variable. All right, so we're going to attempt to cast C1, which really is a feature request, to feature request and store the resulting reference in F1. And that worked. There we go. F1 is, if we drop this down here, it's the feature request that we wanted. These guys now refer to the same thing. Remember, classes are reference types. They are all about two things can refer to the same thing. All right, now C2 is a defect fix request. So what's going to happen here? You'll notice the compiler allowed this program. The compiler allows the cast from the less derived type, change request, to the more derived type because it might work. We know it might work because it just did. But if we try to step over this code, you'll see we get an invalid cast exception was unhandled because this thing really isn't a feature request. Right? It's a defect fix request. Those are not the same thing. And the compiler, or the runtime, is now telling you, you were wrong when you wrote this program. This program contains a bug. This is one of the boneheaded exceptions that I talked about in a previous episode. This is an exception that should never happen in correct code. Right? You don't want to be handling this exception. You want to be eliminating the buggy code. All right, so let's just stop that for a minute here. I'm going to put a breakpoint there. I'm going to comment out this buggy line of code. What do you think is going to happen when I try to cast C3, which, remember, contains a null reference? What's going to happen when I try to cast that thing to type feature request? It's not a valid reference to a feature request because it's null. Null isn't a valid reference to anything. So let's see what's going to happen here. I'm going to hit start. We'll hit the breakpoint, and now is the moment of truth. We'll try to step over it, and that worked. What value does F3 have? F3 is null. So if you have something that is null, right, then regardless of its type, here the type of the variable is a base type, you can cast that thing to a more derived type. You will get another null reference. So basically, this is saying an invalid reference to a change request can be used anywhere that an invalid reference to a feature request is needed, right? But it's still invalid. You just don't get an exception. All right, so that's casting. And casting is probably the worst. Well, it's not the worst of our options. We'll see an even worse option at the end of this video. But it's still not very good because, as you can see, it can fail. And when it fails badly. Right? It causes the program to halt. All right. So here are a few ways that you can do this without everything exploding. The first way is to use the is operator. So this is an operator in C#. It's just like plus or minus or times or divide, except that addition and subtraction and multiplication and division take an integer on either side of them, or a double on either side of them. Whereas this guy takes some kind of reference on one side, some kind of expression, and it takes a type on the other. So we're saying, OK, if C1 is of type feature request, then this expression will be true, and we will step into the body of the if. And it is. All right, so now, when we've gotten here, now we have solid evidence that this cast is not going to fail. Right? We know that the variable is actually referring to an object of the type that we want, so we can do this cast safely. Right? And so we do that, and then we can write out the name of the person who's doing the request, which is Leah. All right, so now what's going to happen if we try to do that to C2, which you remember is a defect fix request? Well, now the runtime is going to say, this is not a feature request. I cannot possibly make this conversion, and therefore I'm going to produce false when you ask me, is this thing of this type? No, it's not, so we skip the body of the if. And what are we going to do for the null case? Now, on the one hand, you might say, well, we did manage to successfully cast null to the feature request type, so maybe this thing is a valid feature request. Or you might say, well, this is a null reference. A null reference does not refer to any feature request, and therefore it is not. So once again, we have the moment of truth. What's this going to do? It skips over the if. OK, so the meaning of the is operator is it takes the expression and it says, is this thing a valid reference, a valid non-null reference that is compatible with the type that is on the right-hand side? And in this case, it is not, because the reference is null. So hopefully that makes sense. Right? When you use the is operator, you are asking, is this thing really something that I can use as this type? And so that then brings us to the as operator, right, which essentially answers the same question. It just kind of takes a few steps out. So let's use the as operator 3 times. Now the difference between the is operator and the as operator is the is operator gives you back a Boolean that tells you whether the expression is compatible with the given type. The as operator actually does the conversion for you. It actually does the cast. Though it doesn't use the cast operator, it uses the as operator. So let's take a look at what happens here. And I'm just going to step through all of these. So we've tried to get 3 feature requests. C1, which really is a feature request, has caused F1 to become that feature request. So this has worked, right? So we've done the is check, and we've done the cast all in one step. C2 is not of the correct type, so F2 becomes null. We do the check, and it says, oh, this thing is not compatible with the type. I'm going to give you a null reference instead. And C3 is a null reference. And once again, we have said, OK, well, this thing is not a reference to the kind of thing that we want, and therefore we're going to give you null. All right, and so now we can say, well, if the reference that we got is not null, then we can dereference it, just like that. And so once again, we can get the name of the person who's doing the request out of the change request. So is and as are kind of basically the same thing. They are both asking the question, is this expression compatible with the given type? The difference is gives you back a Boolean that says yes or no, and as gives you back a reference that is either valid or null. All right. So here's an interesting question. We said that there is a universal base type, the object type, that is the base type of everything. And so let's see what this does. Right? We should be able to assign C1, right, which remember is of type feature. It refers to something of type feature request. C1, the variable, is of type change request. We should be able to assign that to a variable of type object, because object is the base type of change request. All right. So now, what happens if we try to go the other way and say, I would like to turn this object, this reference to some object, which is really a feature request, I would like to turn that back into a change request. Remember, C1 was a change request that contained a reference to a feature request. Is this going to say, oh, I'm sorry, this object is actually a reference to a feature request, and therefore it will be null? Or is it going to say, oh, the object is actually a feature request. A feature request is a kind of change request, so I am going to give you the reference that you want? Well, let's find out what happens. This guy is non-null. So you can use the as operator to say, is this thing compatible with one of its own base types? Right? So in this case, the object refers to a feature request. A feature request is a kind of change request. Therefore, it is compatible. And therefore, we can say, well, if we wanted to treat this object reference as a change request reference, could we do that? Yeah, absolutely, we could do that. So we'll let you do that. So the important thing to realize here is that the is and as operators are not about what is the actual type of this thing. They are always about, can I use this thing as the given type? So with that in mind, here is a third technique that you almost never want to use. But I mention it for completeness and because you'll sometimes see this in other people's code. So here, I'm going to call a method on C1, remember, which is a feature request. Every object in C# has a method called getType. And that returns an object that describes the type. This feature of the runtime is called reflection, because you can think about it sort of as reflexively looking at itself to understand what the type is. So we can then ask, is that equal to the type object that is associated with the type feature request? So this is another operator of C# called typeof. And inside parens, it takes the name of a type, and it gives you back that type object. So in this case, we're going to say, well, C1 really is a feature request. So the type object that comes back will be a feature request type object. They will be equal. And now we have good evidence that we can do this cast without it crashing. So that worked. All right, so what if we say, is C2 a feature request using this same technique? And of course, that will fail, right? Because this guy really is not a feature request. It's a defect fix request. So this will be the type object for defect fix request. This will be the type object for feature request. They're different. OK, now what's going to happen if we call getType on C3, which remember is null? We get a null reference exception. So this is one reason why you should not use this technique, is because it only works on things that are non-null, right? This C3 is the receiver of this call. And we know that except in very special circumstances involving some methods on nullable value types, the receiver of a call has to be, if it's a reference, it has to be non-null. All right, so let's get rid of this code here that crashes. And now we'll start the program over again. We'll just step right down to here. All right, so keeping in mind what I just told you about how the as operator works, what do you think this is going to do? We're going to ask, is C1, which is, remember, a feature request, is its type object the same as the type object of change request? Now remember, with the as operator, it said, why, yes, C1 is totally compatible with change request. Change request is its base type. If you want to use this thing as a change request, you go right ahead. Well, this fails. It steps over the body of the if because this thing is false. The type object associated with C1 is the type object for a feature request. The type object for change request is not the type object for feature request. They're different objects. And so therefore, they are unequal. And therefore, this technique for type testing has failed. So that's why you should probably avoid this technique for two reasons. One is it doesn't deal with nulls. And the other is it does a check on the exact type and not whether the types are compatible. Now, there are other things you can do with reflection to ask, is this type compatible with that type, and so on. But if you're going to be doing that, then you might as well simply be using the as operator or the is operator. I want to take a look at this in just slightly more detail. I'm going to actually fetch the type object. The type object is a reference to an object of type type, which is a little bit confusing. There's a kind of a strange loop going on here. But we can take a look at this thing, and you can see that all of the information that you would want to know about this type is properties on the type object. So what assembly it's defined in an assembly called video 18, version 1 of that assembly. And there's just lots of stuff in here, right? What's the base type? The base type is change request. And then there's all kinds of stuff in here about, OK, well, what constructors does it have? What fields does it have? And so on. So you can do a lot of introspection on a type using type objects. We're not going to talk about that much more in this course. All right, so that's the as and is operators. How do they work with value types? And so far, we've only been talking about reference types. So let's remind ourselves how value types work here. I can make a variable of type int and a variable of type double. I can assign the variable of type int, this expression here, to this double, because the compiler knows that there are strictly more doubles than there are integers. Every valid integer has a corresponding valid double, and so it allows the conversion between the two. Now, something we have not done before is said, you know what? The base type of even the built-in value types is still object. And therefore, it seems that we should be able to assign a value of type integer to a variable of type object. And in fact, we can do that. This in C#, this is a special kind of conversion. This is called a boxing conversion, because you can imagine what happens is you put the integer into a little box, and then the object variable has a reference to that box, because remember, object is a reference type. All right, so now we're going to ask the question. We've put this integer into a box. We've then stuck a reference to that box into this variable. Is this thing an integer? And as you would imagine, the answer is yes. Right? This guy is an integer. Now, what about this double here? Now, we assigned an integer to that double. But the question that we're asking here is, was a double put into this box? Does this object reference refer to a double, or does it refer to an integer? And this says false. That double is not an integer. That double is a double. Now here's an interesting question. This integer, we know, is compatible with the double type. We could do this assignment no problem. So when we ask, is this integer object a double, should it say yes or no? And it says no, it is not. So the is operator, when you are dealing with value types, requires an exact match, right? It does not answer the question, could I have assigned a value of this type to a value of that type? It only does that for reference types. For value types, it is strictly going along the basis of, no, really, what is this thing? Is it an int? Is it a char? Is it a bool? Is it a double? Is it a decimal? And not what are all of the possible relationships between those things involving assignment compatibility. All right, and similarly, if we make these things nullable, you would find that there are similar relationships there. Now, what if we try to use as? I'm going to stop this program here and uncomment this code. We know that the is and as operators are closely related. We could ask if this object is a double, so we probably should be able to ask it to give us that double. But this gives an error here. What's the error? It says the as operator must be used with a reference type or nullable type. Double is a non-nullable value type. So remember what the operation of the as operator is. The as operator says, I'm going to check to see if this expression is compatible with this type. If it is, I'm going to return you back the expression converted to that type. If it is not, I'm going to give you back null. OK, well, let's suppose this double object here was not a double. What's the as operator going to give you back? Right? It's got to give you back null, but you're telling it that you always want a double. Right? And there is no null value for doubles. So what you have to do here is you have to say double object as nullable double, and then make this a nullable double. And now we can check. If this thing really is a double, it will hand it back to you. If it is not a double, then it will hand you back a nullable double. Now what happens if we try to cast this object that contains a boxed integer? What happens if we try to cast that to double? Right? Remember I said earlier that the cast operator can be dangerous. But it seems plausible that this should work, because after all, we just did convert this integer object to a double. So it seems likely that it should work. Well, let's start it and find out what happens. And if we try to step over this thing, then we get an invalid cast exception. So there is a rule for boxed value types, and that is if you are casting them back to a value type, the types must match exactly. So we can cast this integer object. We could cast it to int, or we could cast it to nullable int, but we cannot cast it to any other type, even if the integer would have been compatible with that type. The reason for that is complicated, but it has to do with how the C# compiler would need to generate the code in order to make it work. The code would be very long and it would be very slow. And so the language design team has opted to make the operation simply fail rather than generate all of the code that would be long and slow in order to make it work. All right, summing up, try to avoid situations where you have to test a reference for its type. If you have a method that takes an object of it takes a reference to a base type, then you probably want that method to be treating that object as though it were of the base type, rather than asking, well, are you really of this more derived type? Code that tries to interrogate things to find out what its type really is often inelegant code, easily broken code. But if you do have to do it, and there are some situations where it's unavoidable, then there's a bunch of stuff you can do. If you are in a position where you are certain that you know that a conversion will work, then you can use a cast. If you are not, then you can use is and get back a Boolean that tells you whether the cast would work. Or you can use as, and it will do the conversion for you. Be careful when using is and as and casts with value types. particularly if they are boxed value types. Those conversions don't necessarily work the way you would want them to. And avoid using the get type object for type testing. There are some very limited situations in which that's appropriate, but almost always you want to use is or as if you're not sure of what the type of a thing is.